Hey, welcome back. Another tool grinding project. I have some parts out of PMMA plexiglass that require a 10mm push-in fitting. Hose goes on this side and this side has a thread. This happens to be a pipe thread, a G3/8 inch pipe thread, and I don't have a tool for that. Considered thread milling it, consider turning it, settled on turning it because, well, I like turning. Also, grinding the tool for turning is easier than grinding a thread whirler, which is also very possible, but a single point tool is easier in this case. So, of course, I could just order a tool or an insert for doing this thread, but I don't have an inserted threading bar that's small enough for this, and I'm not in the mood to order a €50 boring bar for 2 threads. Also, tool grinding is fun for me, so I'm going to do it this way, even if it's not 100% economical. Can't use a standard metric threading bar because this pipe thread has a 55-degree angle on the thread. Let's look in the book. This is what we're dealing with. A Rohrgewinde, which is a pipe thread, Rohrgewinde DIN ISO 228-1. And the diameter is a G3/8 inch, 16.66mm OD. It's a 19 threads per inch thread, and the metric pitch would be 1.34 millimeters per revolution. And as you can see up here, the radius is 55°. So we need a tool for this. I'm going to make a solid carbide boring bar on the surface grinder, very similar to this one. This is just a straight boring bar for doing. I used this to do a tapered bore in some grinding wheel hubs that I made for the surface grinder, and just whipped this out of a piece of 8mm carbide round stock. It has clearance ground into it on the side here, but not on the back, so it's just, I only removed as much material as needed and as little as possible to keep it as stiff as possible. Split in half here, ground a 45 on here so chips don't bunch up behind this step. Has all the clearance angles needed, and a tiny radius stoned onto it. Very simple tool, can be made on a surface grinder or also very well on a D-bit grinder. Making one of these on a D-bit grinder I have a video on, I think, including a little bit of a fixture to create the eccentric offset. My D-bit grinder is still in a project state, so using the surface grinder today. Oh, and the tool cutter grinder is sold. It's still here, but it's not mine anymore, so not going to use that. Surface grinder it is. Using my old friend, the punch grinding fixture, and a piece of 8mm solid carbide, ultra micro grain carbide here. And the screw is of course too short, so we're using a backer block for the screw here. This is in general better practice anyway. Instead of pushing with the screw against the stock, just use a block to spread out the load. Surface ground on both sides, so no problems there. I want some reasonable overhang. I'm making the boring bar for about 20mm depth of cut. The thread I'm doing here is way less, but well, while I'm making it, I can make it kind of universal, and 20mm seems like a good ratio. So it's locking it in place, and it's nice and wobbly. First we will set the eccentricity to grind the side clearance, so the shank of the boring bar doesn't rub on the side of the bore. It's already set to some amount of eccentricity, but I will get a dial indicator in and set it to a number value. The drill press allows me to use a clamp to hold it in place while I indicate the stock in. Oh, okay. I'm setting the throw to 4 millimeters. Roughly 4 millimeters. The indicator is not on center height, so we are measuring a little bit weird. Now that's better. Okay. Let's start here at the lowest point, 3 millimeters on the dial indicator. And when we crank it, we should top out at about 7 millimeters. Yeah, 7 minus a little bit. So we can give it a tiny bit more. This indicator is, by the way, not the most nicest of quality. So I wouldn't trust it a huge amount. But for what we're doing here, just setting clearance, it's fine. 0 and 7 plus a little bit, like 10 or 15 microns. Lock it down completely. Okay, now we have our eccentricity set to grind the clearance. We will grind this orientation with a straight wheel from the top. Transferred it over to a surface grinder on the magnet chuck, spaced off the fence with parallel to give me a little bit more clearance. These are kind of annoying form factor on most grinders, but it is the best what we get for doing round work on a surface grinder. And they are super universal, so you have to take some negatives too. So it would be neat if it was centered under the wheel in this direction, just so our geometry comes out right. Also down feed directly works into the diameter we're grinding. So for very rough alignment, you can just drop down the wheel very slowly and watch the work touch the grinding wheel. And at some point the grinding wheel will drag over the work. There we go. Now the work drags on the underside of the grinding wheel. And this position is pretty much centered below the grinding wheel. In our case, we have to make sure, of course, that our work is not offset to the side, but in the extreme upper or lower position of our eccentric throw. Otherwise, we get very weird results. So we do that, and we set our table stops. So we can work so the table is basically locked in place. Now we can do down feed grinding and create our relief here. I'm going to set the stops. I'm going to push the stop pins through here and set, using the shot pin, I'm indexing here at 90 degrees. And I'm moving the stop here on the side. Oh, okay. Let's move the stop up to the pin and lock it. And then we go 180 degrees, again using the index pin to get our position. And we set the rear stop. And this allows us to grind on a 180 degree arc, extremely precise and very quick to set up. Now it's just a matter of plunging down with the grinding wheel until the clearance that we grind is tangent with the side of the stock. This should happen at a down feed of about 2 millimeters. This end will be our cutting edge. This end will be our cutting end, so we need to split it in half now. For that I put the indexer in a 90-degree position, like this. Just using the shot pin indexer up here. And I will split about 5 millimeters off the cutter in half. For that I need the table to move back and forth. Touched off on the top dead center. Now I'm turning on the dusted scratch and just plunge down. I think that already looks quite decent. Out here on the side you can see that this is kind of rising away. That's because my diamond wheel is tapered to one side. And normally I would grind the other way, but spin fixture only really works in this orientation, so would have to redress the entire face of the wheel, and I don't feel like it for just a little bit of tool grinding. This will do fine. Okay, with the general geometry figured out, now it's time to grind the 55-degree and the clearance angle to the underside. For the 55-degree, we'll just kick the indexer on an angle in 2 directions. And for the clearance to the underside, I will tilt the head of the grinder. Otherwise, I would have to put the indexer on an angle. But since this grinder has a tilting spindle, we can do it the easy way. 55 degrees divided by 2 is 27.5. So I have some angle blocks here. This is ½ degree. Two degrees, and this is 25. And this way and this way. This should give me 27.5 degrees. Just turned the magnet on so everything is magnetized, but now I turned it off again so I can slide the indexer on. Now it's sitting in here, 27.5 degrees, and we will start by grinding the far side of the cutting edge. Oh wait, I figured I better sit up. With this setup I would have to grind behind the wheel, which is a little bit annoying on this machine due to its kinematic layout. So we're going to flip everything around. ½ degree, 2 degree, and 25. 27.5 in total. And here is the indexer. In this orientation I can grind this angle here on this side. It's get my first half of the 55 degrees, and now I would have to change the orientation of the index, but I can just flip it by 180 degrees and grind on the other side of the wheel and create the same angle on this side of the tool, which you can't see now. We're basically removing this side here with this side of the wheel. Not ideal because this wheel is not really dressed for side wheeling, but we're not doing a ton of material removal. This should work out. Tilting is a simple operation. Just pull out these two tapered pins. They have a thread and a nut, so you can pull them out of their seat. Then I like to put something in the tapered bores so grinding dust doesn't get in there. I generally use ear plugs because these are cheap and easy available. Then it's just a matter of loosening this screw here and tilting the head by, I'm guessing, I would say 7, let's go for 8 degrees in the feet direction. Let's go a little bit. Let's go to 10 degrees in the feet direction, just to be on the safe side. If you're doing this long enough, you might develop a habit of double checking everything. In this case, I'm double checking my stack up because the half-degree block here is very easy to get on the wrong way. It's a very shallow taper, but my universal angle protractor reads 27.5 between the fence and the body of the spin fixture, so we're good there. In an ideal world, I would put a lathe tool in a grinding vise and I would remove the aluminum here on the grinding wheel to expose, to have the diamond, the most proud material on this wheel, and not have this aluminum carrier right at the same level as the diamond. This is why the grinding sounded so weird in some cases. Or use a cup wheel as a normal person would. But we need this wheel shape in a second when we do the back side of the threading tool, because I'm going to tilt the head into the other direction. And grind the back side of the tool. I don't even have to tilt the wheel in the other direction. Geometry is hard. I just need to go to the other side of the wheel, and we'll be good. Okay, grinding here on this side, the back side of the grinding wheel. This is horrible to show. Also set the table stop so I don't run into something. The nice thing about using the punch grinder on the surface grinder with the magnetic chuck, it's very easy to take this off and take it over to a measuring implement, either the surface plate and using sine bars, or if you have one, a profile projector or a shadow graph if you have one. Or in my case, since I got this beautiful Nikon MM40 measuring microscope, I will do a video at some point in time about this microscope, but it needs work, but it can measure, and it can measure precise. It has linear scales in the table, so any slop of the feed screws is not an issue. But I can use it to measure the angle of the cutter that we just ground using the Quadra-Check measuring computer that it came with. So what you can do with this is you can create geometric equations. For example, you can measure an angle between 4 points. 4 points, 2 points define a line, 2 other points define a second line, and you can get the angle between those 2 lines, and that's what I'm going to do on this cutter that I just ground. Nice thing is the indexer doesn't have to be aligned on the bed of the microscope in any way, because we're defining 4 points. So picking up the first point of the first line, and since it's an optical measurement, it is prone to error. So I checked measure angle. Now it wants a line defined. Enter. A line can be defined in a Quadra-Check between 1 and 50 points. 2 points will do fine in our case. So point 1, already in position. Now it wants a second point. Moving over. Yes, the microscope has a camera port, but I don't have all the glassware to mount the camera. So I just entered point 2. Now the first line is defined. Now it wants a second line. Okay, let's move to the start of the second line, which is the other side of the cutting tool. And we hit enter. Point number 1, enter. We move to point number 2. Hit enter for the second point. Hit finish, and we get 55 degree and 30 arc minutes. So there is a little bit of error from the grinding setup because we're just using the angle blocks against the fence, and there is also a little bit of error from the grinding wheel itself because it's not dressed perfectly, and also there is a little bit of error from optical pickup, me picking up the corners of the tool. This is only 30x magnification, and for the level of accuracy that this microscope and the linear scales and the Quadra-Check can deliver, I think I would like a 100x total magnification. A terrible setup with the microscope through the eyepiece, but you get the idea, I hope. So this top surface here is the chip creating surface. This side, this cutting edge here, this is the one that we ground with the grinding wheel working into the carbide, and you can see that it's a nice crisp edge. Apart from the grinding wheel being fairly coarse, it's a D126 wheel, which I would consider a good all-purpose wheel, but not a finished grinding wheel for carbide cutting tools. But the cutting edge is in general very clean, and there is no chip out. On this side, we ground with the wheel coming out of the carbide, pulling upwards or downwards because it was overhead. But you can see there is like a black line going along the cutting edge, and that black line, that's chip out, that's micro chip out from the carbide with the grinding wheel running in the wrong approach to the carbide. So that's why it's kind of important to always grind into the carbide and not out of the carbide. In this case, I'm not overly concerned about it because I'm threading plastic. I will put put a diamond cup wheel, a very fine cup wheel on the grinder, and that will touch off the top surface, and that will take care of all the chip out. But I think it's a good demonstration so you can see the actual chip out, and not only hear people talk about the chip out from grinding outside of out of the carbide instead of into the carbide. I wish this microscope had a little bit more magnification. I will go for on the hunt for a higher magnification lens for it, but for now 30x will do it. Also, you see that the tip of the tool here is dead sharp and has 0 corner radius. I will take a ruby stone to it and just break it ever so slightly into a radius later. I put the D25 superfine diamond cup wheel on the grinder, and apparently the wheel guard fell off in the meantime. And on this wheel, you might notice that up to this point, there is no grinding noise. Because with this wheel, I try to keep a good practice of feeding in on the inside, like this, and grinding towards the outside. That way I keep kind of a sharp edge on this wheel. So in the rare cases when I have to grind with the corner of this wheel, I have a sharp corner and don't have to recondition the entire wheel each time. Okay, now for the other side of the tool. For that I have to flip the cup wheel. On a CNC grinder, you would have, for example, a wheel package with a number of wheels on it, so you can grind in both directions. Okay, I'm not going to do that on the machine because here is a sharp tool and I don't want to slash myself. Not in the right mood for that today. With some creative stacking of spacers, I now have a reverse grinding wheel that looks like this. Okay, here you get a view on the two cleared surfaces. These now have a marvelous good finish. The D25 wheel that I have here really leaves a nice finish. And if I ever get around to edit the video that I filmed at Kern, where we played with the electron microscope, and I put some carbide under the microscope, ground with this wheel, you will see how good of a cutting edge this will leave. So second to last thing is going to kiss the top surface with the same cup wheel, and then we grind this 45-degree lead out just to make it a little bit nicer. Getting the grinder back in a normal position, we pull our earplugs. We open the lock screw for the rotation, and we find our two tapered pins. We make sure they are clean. Back off the draw nut. we get them back in. Use a copper drift to seat them a little bit and fully tighten the head. Move the draw nuts all the way up to the casting, or it's not a casting, it's a solid machined spindle head. Move the nuts up all the way so they don't rattle around, and we're back in normal operation. Now we flip this wheel around again. Because I'm bad at planning ahead when I do video, first we get rid of the punch grinder, because it's currently in the way. That's the nice thing about the magnetic chuck. Stuff goes on and off so quickly, it's not even funny. It's a lovely tool. So let's switch to the 1A1 to a straight wheel, knock the 45-degree chamfer on it, and it's done. Kick the punch grinder at 40 degrees, and I'm just going to cut this little chamfer on top of this tool. I'm just going to sink it down and then move it into the corner that I created by splitting the blank in half. So first we get all of this stuff off the machine. This adjustable magnetic transfer block was given to me by a friend, and this is really a lovely item for things like tool grinding, because it's super fast to set up. So for sawing off the carbide, I'm just going to use a grinding vise. How long do we want the tool? A little bit on the longer side, I guess. I would say let's see. Okay, I have the tool again under microscope, and I checked the angle again after finish grinding, and now we come out to 55 degrees and 3 arc minutes. So this is plenty accurate, considering all the errors from optical measurement. This should be fine. With the lathe, I have a piece of Delrin. I bored it to approximately 15 millimeters, which should be the bore size diameter for a G3/8 inch pipe thread. Set the tool up, it's on center height. The bore is chamfered. I'm going to cut a thread relief in the back using the threading tool. I already touched off on the face of the part with my threading tool, so I have an idea what's going on. And I move in 9 millimeters, going to plunge out and move 2 to 3 millimeters over to create a thread relief. We'll cut the part open later to see what I did in there. Okay, and now we can start threading. I'm running a 3D printed change gear in the machine because the standard gear set of this machine cannot do 19 threads per inch. So I 3D printed a 95 tooth gear, and I'm just using that for now. Don't have any phenolic in the house to mill a proper change gear currently. It's ordered, so back at machining changes. Yes, I know. Electronic lead screws exist. The loud ka-clong noise that you hear each time is the spindle brake, or the motor brake, by the way. So let's go to the theoretical dimension. Okay, let's see what we get. There we go. Almost overshot it, but yeah. That looks like a fine thread to me. Yeah, that's fine. So now I have an idea of my needed dimensions. And let's cut it open and look at the threads. And here we are. I cut the test part in half, and a terrible job at deburring it, but I think you can see that the thread itself came out very clean. And when we put the fitting that will screw in here inside the thread, it fits very nicely. I overbored the hole for the thread by 0.3 millimeters since I didn't have the tool, the boring bar calibrated on the Euro. So the crests of the thread look a little bit weird with the correct pre-drill it will look way nicer. But worked out fine. I took a ruby stone and I worked a tiny radius on the tip of the threading tool, just by hand, looking at it under magnification, and that's the result. I'm very pleased, and given the chip the tool produced, I'm not worried that it will work in the plexiglass. Unfortunately, I cannot show the plexiglass parts once again, but with the tool grinding and the test part, I think I still got something worthwhile to watch out of it. I hope you enjoyed this little tool grinding exercise and the little demo of the Nikon microscope. As I mentioned, the tool and cutter grinder is sold. I noticed that I didn't use it for very much in the last 6 months. I slowly had used the surface grinder more and more, just because it's very convenient and it has digital readout, and it's a very quick machine to set up for the odd regrinding jobs. The S1, as it's a full tool and cutter grinder, is definitely the better machine if you have to do back relief grinding, like spiral relief grinding or spiral grinding in general, because it has the spiral grinding attachment. Also, it's better for large tools like very long drill bits. I've ground like 40 millimeters super long drill bits on the grinder, and for that kind of work the S1 really is excellent, since it has a very, very large work envelope for the footprint of the machine. Also, saw blades worked very well on the machine. But from now on I will have to live with the surface grinder alone. I need a little bit more space to move around in here. The area where the tool and cutter grinder used to be will probably occupied by just a lister cabinet. So that's that. In one of the coming shop talk videos, once the grinder is gone, I will do quick tours through the shop, how stuff is laid out now. So have a nice week. Thank you all for watching, and I'll be back.